Hello students, in the previous session we introduced ourselves to variance and standard deviation. In this session we shall solve some problems to understand them better. Calculate the mean, variance and standard deviation for the following distribution. We have the class intervals as 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80 and so on till 90 to 100. And corresponding frequencies are 3, 7, 12, 15, 8, 3 and 2. Look at the solution now. From the given data, we can construct the following table. First column shows the class intervals, second column shows the frequency Fi, and then we calculate the midpoints Xi's as 35, 45, 55, 65 and so on till 95. And fourth column shows us the product of Fi and Xi, that is 3 into 35 gives us 105, 7 into 45 gives us 315 and we can calculate in the similar manner and also calculate the sum as 3100. Next column shows us Xi minus X bar whole square, that can be computed as 729, 289, 49, 9, 169, 529 and 1089. Last column shows us the product of Fi and Xi minus X bar the whole square, that gives us 2187, 2023, 588, 135, 1352, 1587 and 2178. That gives us 10050 as the sum. Thus, mean x bar is equal to 1 upon n into summation I varying from 1 to 7 Fi Xi, that is equal to 3100 upon 50, that is 62. Variance sigma square can be calculated as 1 upon n into summation I varying from 1 to 7 Fi into Xi minus X bar whole square, that is equal to 1 upon 50 into 10050. This on calculations gives us 201. And standard deviation sigma is equal to positive square root of 201, that is 14.18. Now let us solve an interesting question here. Find the mean, variance and standard deviation using shortcut method. Height in centimeters are the observations given, lying between 70 to 75, 75 to 80, 80 to 85, 85 to 90 and so on, varying till 110 to 115. And number of children corresponding are 3, 4, 7, 7, 15, 9, 6, 6, 3. Now let us look at the solution. Here we prepare a table. First column representing the class intervals, second column representing the frequencies mentioned in the question, third column is showing you the mid values Xi, that can be calculated as 70 plus 75 upon 2, 75 plus 80 upon 2 and in a similar manner we can complete this. Then come to fourth column. This shows the deviations from mean. Di is equal to Xi minus 92.5 upon 5. This 5 is the width of this class interval, 75 minus 70, that is 5. Now we get the values as minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4 respectively. Next column shows us di square, that is square of the deviations. 4 4s are 16, 3 3s are 9, 2 2s are 4 and so on. Next column gives us the product of Fi and di, that is 3 into minus 4 is minus 12, 4 into minus 3 is minus 12, 7 into minus 2 is minus 14 and similarly we can find out the sum, it comes out to be 6. Last column shows us Fi di square, that can be calculated as 48, 36, 28, 7, 0, 9, 24, 54 and 48. On adding it gives us 254. Here let assume mean A be equal to 92.5, H is equal to 5. Mean can be calculated as A plus summation Fi di upon summation Fi into H, that is equal to 92.5 plus 6 upon 60 into 5. That can be calculated as 92.5 plus 30 upon 60, that is equal to 92.5 plus 0.5, that gives us 93. Now, variance can be calculated as summation fi di square upon summation fi minus summation fi di upon summation fi whole square into h square. Using the values, we have 254 upon 60 minus 6 upon 60 whole square into 5 square, that is equal to 254 into 60 minus 36 upon 60 into 60 into 25, and this can be calculated as 15,240 minus 36 upon 60 into 12 into 5. That gives us 15,204 into 5 upon 720, that is 105.58. Therefore, standard deviation sigma is obtained as positive square root of variance, that is equal to positive square root of 105.58, that gives 10.27. Now, students, let us discuss about analysis of frequency distributions. In earlier sessions, we have studied about some types of measures of dispersion. The mean deviation and the standard deviation have the same units in which the data is given. Whenever we want to compare the variability of two series with some mean which are measured in different units, we do not merely calculate the measures of dispersion, but we require such measures which are independent of the units. The measure of variability which is independent of units is called coefficient of variation, denoted as CV. The coefficient of variation is defined as CV is equal to sigma upon x bar into 100, where x bar is not equal to 0, and sigma and x bar are the standard deviation and mean of the data. For comparing the variability or dispersion of two series, we calculate the coefficient of variations for each series. The series having greater coefficient of variation is said to be more variable than the other. The series having lesser CV is said to be more consistent than the other. Now, let us discuss about the comparison of two frequency distributions with same mean. Let x1 bar and sigma 1 bar be the mean and standard deviation of the first distribution, and x2 bar and sigma 2 be the mean and standard deviation of the second distribution. Then the CV in the first distribution can be expressed as sigma 1 upon x1 bar into 100, and coefficient of variation for second distribution is equal to sigma 2 upon x2 bar into 100, given x1 bar is equal to x2 bar, that is equal to x bar say. Therefore, CV for first distribution becomes sigma 1 upon x bar into 100, take this as first equation, and CV for second distribution becomes sigma 2 upon x bar into 100, take this as equation 2. It is clear from 1 and 2 that the two CVs can be compared on the basis of values of sigma 1 and sigma 2 only. Thus, we say that for two series with equal means, the series with greater standard deviation or variance is called more variable or dispersed than the other. Also, the series with lesser value of standard deviation or variance is said to be more convenient than the other. Let us solve an example to understand this. Two plants A and B of factory show following results about the number of workers and the wages paid to them. Here we have two plants A and B. Number of workers are respectively 5,000 and 6,000, average monthly wages are ranging here as 2,500 for A plant and 2,500 for B plant. Variance of distribution of wages is 81 for A plant and 100 for B plant. The question is, in which plant A and B is there greater variability in individual wages? Let us solve this example. The variance of the distribution of wages in plant A, sigma 1 square is equal to 81. Therefore, standard deviation of the distribution of wages in plant A, sigma 1 is equal to 9. Also, the variance of the distribution of wages in plant B, sigma 2 square is equal to 100. Therefore, standard deviation of the distribution of the wages in plant B, sigma 2 is equal to 10. Since the average monthly wages in both the plants is same, that is 2,500 rupees, therefore, the plant with greater standard of deviation will have more variability. Thus, the plant B has greater variability in the individual wages. So, students, hope you enjoyed studying this chapter on statistics. Thank you.